Okay. So what about the isolated footing with axial bending in the both axes? Okay. So nung kanina, okay, like this one. So this is the pressure diagram of our single axis bending. So as you can see, yung isang side lang yung meron tayong parang meron tayong two values of pressure, di ba? Parang kung nasaan yung may compression side and nasaan yung tension side. Okay? So ito yung mga point na yun. So ito yung parang compression side and this one is yung tension side. Okay? But in the case of an isolated footing with axial and bending in the both axes, so you have four pressures. Okay, you have four values of pressure at the ends. So those four values of pressure at the ends is QA, Q sub B, Q sub C, and Q sub D. Okay, so what are those values? Okay, so the same solution to the actually loaded footing except for the assumption of the pressure at the soil. So this time, meron tayong four possible cases. So what are those possible cases? So pwede tayong magkaroon ng, since we have bending in the X and the Y axis. Okay. So we have bending in the X and the Y axis. So therefore, meron tayong four cases dito. Ito yung negative P over B times L minus MX, okay, SX, okay, both minus, okay, so both all are compression, okay, then this one okay, then pwede naman isa na positive MXSX, negative MY SY, and lastly negative P BL, positive MXSX, then positive MY SY. Okay, so yan yung mga cases. Okay, so dalawang case for MXSX or the stress the bending stress in x-axis, and two values for the bending stress in the y-axis. And take note of this when we are designing our footing with both axis bending. So they use a Q average, which is QA plus QB plus QC plus QD divided by 4. Okay, so itong assumption na to, para mas mapadali yung pagde-design, okay, is using a Q average or the average of the four values. Okay, so after getting the average of the four values, we can now assume that those values are applied uniform. Okay, meron na tayong uniform pressure after using this Q average. Okay, so let us try. Okay, so this again is an example problem from structural engineering by Besavilla, or it is a passport exam. Okay, so a spread footing supports a 350 millimeters by 350 millimeters column carrying a dead load of 300 kilonewton and a live load of 500 kilonewton. So the footing is subjected to an axial moment produced by the effect of the dead load, live, and the earthquake. So the unfactored moments are tabulated below. Okay, and the thickness of the footing is 460 with an effective depth of 360. Okay, then the bottom of the footing is 1.2 meters below the ground surface, a unit weight of the soil which is 15.7, and a concrete of 23.5 kilonewton per cubic meter. Okay, then the question is, which of the following gives the dimension of the spread footing? Which of the following gives the punching stress at the critical section? And which of the following gives the number of 20 millimeter diameter bar in both ways for the footing? Okay. Okay, so let us try. Okay, so hindi pinanggit dito what are the codes. So ito ay passport exam ng NCP 2001. So yung load combo dito class is 1.4 dead load plus the 1.7 live load, and yung isa na what is this? Okay, wala naman na. Okay, I think yan yung load combinations. Okay, so yeah, let us try. So, ang sabi dito, the dimension of the spread footing is we have okay, 1.2 below the ground surface. Okay, so unknown yung dimension of the footing. So we need to determine first the dimension of the spread footing. Okay, so if you remember how to solve for the dimension of the spread footing, we need to equate the actual soil pressure to the QE, Q sub E, or yung effective allowable soil bearing capacity, yung Q sub E. And we need to use unfactored load. Okay. So for the total axial load, unfactored, that is 300 plus 500. Ito siya. So 300 plus 500. So you get 800 kilonewton. Okay. The total moments on the x-axis, which is 50, 60, and 36. Okay. So 50, 60, and 36. And the total moments in the y-axis is basically 30 plus 50 plus 29. Okay, which is equals to 146 and 109 kilonewton meter respectively. Okay, we want to simplify our answer, and gusto natin that our B and L are the same. Okay, so gusto natin same siya. So square footing gusto natin i-design. So this is your B and L. So let us use the notation L. Okay. So if you recall, dun sa ating formula, it should be the pressure, actual pressure is equals to the sum of the axial load, pressure due to axial load, the pressure due to the bending in the x-axis, and the pressure due to the bending in the y-axis. So basically ganyan lang yun. Okay, so mas maganda if we consider the signs. Okay, consider the sign. So, what do you think is magbibigay ng malaking value is, syempre, yung i-add mo silang tatlo, di ba? Lahat sila should be in compression. That is the maximum value. So, eto, this one, and this one. Yan yung magbibigay ng maximum value of soil pressure. So, therefore, we need to equate the maximum value of the soil pressure to the allowable or to the effective soil bearing capacity. Okay, so if you recall the formula for the flexural stress, that is MC over I, and it can be equated to M over SX. And the section of modulus for a rectangular or a square is basically BD squared over 6. Or you can now use 6M over BD squared. So therefore, we have our 6mx BD squared, that is for Ix, and 6my over dB squared for the y-axis. Okay? So since now your B and D, take note yung B and D na to, hindi yan effective depth, and yung isang width B, hindi yan na. That is your dimension of the footing. Okay? So since parehas naman tayo ng sides, which is both L, so we can now use L cube and L cube. Okay. So therefore, that is 6mx over L cube plus 6my over L cube. Okay? And so ipa-plus lang natin silang lahat. Okay, so consider natin yung sign, pwedeng it is also the same din sa FA, which is equals to negative P over L squared minus 6mx over L cube minus, okay, wala, FA is equals to negative P over L squared minus 6mx over L cubed minus 6my over L cubed. Therefore, that is our working equation. So for the effective stress, we have your QA, which is 300 kPa, that is the allowable soil pressure, minus natin yung, where is the, okay. Okay, hindi nabanggit yung allowable soil pressure. Okay, I think hindi siya nabanggit dito. Okay, for the allowable soil pressure, use QA, which is 300 kPa. Yan. So for the effective stress, 300 kPa minus mo yung depth of your yung soil, height of the soil. So 0.74. So saan galing yung 0.74? According to the problem, your footing is 1.2 below and your column with your footing depth is 460. So 120 minus 460, you get 740. Okay, that is why 0.74. Okay, so this is the unit weight due to soil, and this is the unit weight due to concrete, and there is no unit weight, there's no pressure or surcharge pressure at the top. So therefore, your Q sub E is 277.57. Okay. So therefore, okay, and also to equate this effective stress, gagawin natin, equate natin yung effective stress. So basically, 277.57, equate it to the ito, yung soil pressure natin. So equate natin sila. Okay, so 277, actually ito na sila eh. Ito na yung equation na yun. Okay, so 277.57. Okay. Okay. So ganito siya. So pwede mong i-equate. So let's say this one, 277.57. Equate it to 800 over 2.3 squared. Should be L squared. Should be L squared. Okay. So kapag gagamitin mo yung negative sign, so gagamitin mo rin itong negative sign. Okay? Ganun lang. Pag gagawin yung negative lahat yan, so gagamitin yung negative side din yung allowable soil pressure. So kung gusto mong i-consider lahat ng signs. Okay? So 800 over L squared, 6 times 146 over 2L cubed plus 6, 109 over L cubed. Okay, your L is equals to, okay, let us get our calculator. Okay. So 277.57 equals to, okay, 800 over x squared plus 6, 146 over x cubed plus 6, 109 x cubed. So gamit tayo ng mas malapit na values. So we get 2 point, okay, nakuha natin is 2.298. So we can now use, therefore, 2.3 meters. Okay, round up always. Okay. Round to the nearest tens. Okay. So yan yung gagamitin nating value. So you can check or recheck the actual pressure, and since that is always less than your Q sub E. Okay, so therefore your dimensions are 2.3 by 2.3 meters. Okay, so ganyan lang yung pagsosolve for the soil pressure. Okay, ang good thing about this problem is the dimensions of the footing is the same. So the same yung dimension of the footings on the X and then the Y, or yung L by L. Okay. The question is, what if kapag magkaiba kayo ng dimension? So anong gagawin niyo kapag magkaiba ng dimension? Okay. So ganun lang din. Kunin mo lang din itong pinakamalaking soil pressure. So yung magbibigay lagi sa'yo ng malaking soil pressure is when you add all the three stresses. Okay, yan yung pinakamalaking soil pressure. And kung gusto niyo consider yung sign, you just need to use negative value for the Q sub E. And paano nalaman yung most stress corners? Okay? So hanapin niyo lahat dito yung may compression sa X, compression sa Y, and yung merong compression hanapin niyo dito yung may compression X and compression Y. So kung ganyan yung inyong moment sa X, okay. Therefore, ito yung most stress, ito yung compression part, ito yung tension part. Okay? Pero kung tapos yung sa MY nyo, kung ganyan yung moment nyo sa MY, ito yung arrow. Yan. One is also your arrow. Okay? So, ito yung compression sa X. Ito yung tension sa Y. Okay? So, ito ay tension. Ito ay compression. Then, kapag ito yung arrow nyo for the Y, therefore, ito yung compression din sa Y. At ito yung sides ng tension sa Y. Okay? So, ito yung side ng tension sa Y. So, kung gagawin natin yung mga signs, okay? Negative, negative, negative. Negative sa force, negative sa X, negative sa Y. Dito naman, which is negative, okay? Negative for the force, P over A. Then also, tension siya sa X. Okay? But, negative siya sa compression siya sa Y. This time sa point D, ito ay negative siya sa X. Okay? Negative siya sa X. Also positive siya sa bending in X. But also it is positive in the bending in Y. And this time, itong isa, this is negative in pressure, force over area. Then it is negative in the x-axis. So tutuldok doon. Okay, tutuldok dito yung x-axis. So compression doon siya. And also, okay, this is tension in the y-axis bend. Okay, so that is the signs on each corners. Okay, yan yung mga signs sa each corner. Okay, so next, what is the punching shear stress? Okay, so just like what we did in single axis bending, we need to determine yung kanilang actual soil pressure, and this time you need to use your factor or load factors. Okay, load combination. So the load combination is 1.4 dead load, 1.7 live load. Okay, so to the P sub U is 1270 kilonewton. And for the MU, okay, for the formula for MU, the load factor for MU is, I think they use 1.4. Okay. Hindi naka-indicate yung sa problem yung load factor. Okay, anyway, sige, pag-aralan natin to this time. So this is 179.49 kilonewton meter using a load factor of 1.4 plus 1.7 plus 1.87 times 0.75. And yung isa naman is 1.4, 1.7. Okay. So therefore, sulat ko lang dito sa labas. Ang load factor pala is This is U1. For U2, that is 0.75, 1.4 dead load, plus 1.7 live load. The problem should state a load combination. And 1.87 earthquake. So imagine meron lang itong meron na ang naka-indicate na load combination sa problem. Okay, this is the load combination. Okay, so you have 179.49. Okay. So and also stated in the problem that use envelope method. Enveloping. Okay, so ibig sabihin kapag we use enveloping, we will get the maximum of each load combination. So kukunin mo yung mga maximum on each load combination. So automatically yung sa point load mas malaki na yung 1.4, 1.7 live load. Kahit hindi mo na i-solve yung isang load combination, ito na yung malaking mag-govern. However, for the case of moments, we need to check. Okay. So for the load combination na U2, ito yung values, and load combination na U1, ito yung values. And therefore, we'll use ito. Okay. Then for the MY, this is the load combination for U2, and this is the load combination for U1, and therefore we use U2 load combination. So again, this is enveloping, so we will get the maximum of each loads on each load combination. Okay, so kunin mo yung malalaki lahat kahit magkakaiba sila ng load combination. Okay, then let us solve for the values. Okay, so ito yung point A. So according to ito yung point A, ito yung point B. This one is the point B, and this one is the point C. So I already give the values. Okay, so the values are negative, negative, negative. So this is for FA. For FA is negative, negative, positive. Okay, negative, negative, positive, or ito ay reaction, so nag-multiply lang siya na nakaibang siya, ibang consideration na reaction forces. So ibig sabihin yung compression dito is positive and yung tension dito is negative. So ito siya. Okay, this one still the same. So kapag mag-multiply ka na, reverse mo lang yung sign dito. So positive, positive, negative, positive, positive, negative. Then on the point B, you have all negative, all compression, and therefore we'll simply add them. In this example, in this solution is yung negative nila is tension, positive compression. Then for FC, which is this one, negative, positive, negative. So meaning negative yung compression, negative yung due to force, okay, positive yung due to MX, and negative yung, compression yung due to force, tension is due to X, and compression yung due to Y. So therefore, you get your positive, negative, positive. Just simply interchange the sign. Okay. Then for FD, point D, negative, positive, positive, still get compression, and both are in tension. So compression, both are in tension. You get your values. Okay. Which is 84.55. Okay. And also, just simply you have your FA, FB, FC, FD. Okay. So ito yung sinasabi ko sa inyo na medyo mahirap or complicated yung pressure diagram when you have both axis bending, since because meron ka ganitong shape. Okay, ito yung force diagram mo. Okay. So ito yung 395.61 kPa, 261.57 kPa, 84.55 kPa, and 218.58 kPa. So kung kukunin mo yung punching shear stress dyan, medyo mahirap kasi kung kailangan mong kunin yung area of that, yung area dito, and magkakaiba yung sides niya. So para siyang truncated prism. So The problem is medyo magtatagal or medyo mahirap yung pressure diagram or yung pagsasolve ng pressure diagram. Okay. So ang solution is to use your Q average. Okay. So just simply average of the soil pressure at the center. So FA, FB, FC, FD divided by 4, you get your 240.08 kPa. And this one, you can now use the formulas or the steps in actually loaded footing, since etong Q average na to, yung Q average na yan is can be assumed as uniform pressure. Okay, this is uniform pressure na. If you're using the Q average. Okay? And basically, alam nyo na sagot yan. Kaya nyo nang gawin itong value na to. So, itong ginamit dito is P sub U minus QU C1 plus T multiplied by C2 plus T squared. Yan yung ginawa dyan. So, you will still arrive for VU kapag ginamit mo naman yung what do you call this, yung Q sub U multiplied by L B by L minus C1 plus D and C2 plus D. Still get the same answer. Okay, let's try. So, okay, you have your 240.08 multiplied by B by L, which is 2.3 squared, minus your C1 plus T and C2 plus T. Ano ba yung C1 plus T and C2 plus T natin? That is 710. Okay, 0.71. Okay, we still get 1148.98 or 99. Okay. So yan yung how to solve for your V sub U sub P. Okay. So 1148.98. And okay, so ito, okay, sorry. So this one and okay, so ito is gonna get this one, and therefore you have your V sub U, V sub P, which is 1.32 MPa. Okay. Okay, then for the steel requirements, so the same on what we did, since now meron ka ng uniform pressure using the Q average or the average solid pressure. Okay, basically parang axially loaded pressure na lang din to. Okay, so your Q sub U is okay. I think this should be 2, 4, okay, 3, 9. Okay. So yung for the steel requirements, you will use yung maximum soil pressure this time. Okay. Yan yung gagamitin mo dito. So let us try. So sa calculator natin. Okay. So this is 395.61 multiplied by the 0.975 squared over 2. Okay, you get your 188 times 10 raised to 6. Okay, so ang some reference, okay, uses yung maximum pressure for the design. Okay, yung maximum pressure. So ito yung Q max. Okay, kasi medyo para yung design nila is over ano na parang conservative na sa lahat. Kasi the problem, if we use 240.08 kPa, so yung paglatag natin ng reinforcement is based only for the 240.08 kPa. And we all know that meron tayong highest pressure dun sa ends Okay, doon sa ends, 'di ba? Doon sa dito sa ends ng B, sa may corner ng B. So ang mangyayari doon sa corner ng B is hindi kakayanin. So pwedeng mangyari mag-start yung crack doon sa ends. Kahit kasi uh, assume that your values is Q average. So, pwede mo nang gawin basically design it to the maximum pressure. Okay, design the reinforcement to the maximum pressure sa bending. Okay. So therefore, you have your Q max, which is 188 times 10 raised to 6, and equate it to phi f prime c b d squared omega and 1 minus 0.59 omega. This is the same dun sa binigay kong problem, binigay kong formula sa inyo, since the omega, okay, omega is equals to, bakit tayo? Omega is equals to omega f prime c is equals to rho fy, or omega is equals to rho fy over f prime c. Still the same. Dito, sunod na yung omega, then after solving omega, equate it to find the rho. So they're still the same. And checking the rho minimum, so since our f prime c is 21 MPa, therefore the governing rho min is 1.4 Fy. So therefore, you will compare your actual rho to the rho mean, which is 0.0041, and they are almost the same. Your rho mean is 0.003, and your rho actual is 0.004. Therefore, we'll use rho actual, which is 0.0041. And AS is equals to rho BD. You have your AS. Then using 20 mm bars, okay, you will have your so ang ginawa solution dito class is ganito. So yung using the spacing, so ang pwede mong gawin is the spacing. Okay, ang spacing kasi class, the formula for the spacing is equals to AB times 1,000 divided by AS. Okay, so ibig sabihin per 1,000 meter strip. Okay, so your spacing is equals to 5 over 4 times 20 squared, multiplied it by 1,000 divided by the total AS, which is 1476. You will arrive to 212.85 millimeter on center. And therefore, you can use S, which is 210 millimeter on center. And to determine the number of bars, just simply divide the total length to the spacing plus 1. Since hindi natin nakakount yung unang reinforcement. So therefore, that is 2,300 divided by 210 plus 1. Therefore, you have 12 bars. Okay. Okay. So meron tayong 12 bars. Pero meron pang ibang solution dito, yung katulad ng binigay ko sa inyo last time. Ang gagawin yung AS is basically solve nyo na yung total length. So, pwede mong AS is equals to rho BD and AS is equals to 0.0041 times 2,300, your 360. You will get your total AS to be 0.0041 times 2,300 times 360. That is 3394.8. Okay, so divide it by n to get your n. That is AS over AB, which is equals to 10.8 and approximately 11 pieces, 11 bars. And this time, hindi kasi nasasama yung first bar, hindi nakakount yung first bar. So you need to add plus 1. So therefore, your total N is equals to 12 bars. Okay. Hindi nakakount yung unang reinforcement. Okay, yung unang reinforcement is ito. Yan. So, kunwari, ito yung spacing mo, hindi siya nakakount. Yan. So, 1, 2, 3. Okay. So, hindi nakakount yung unang reinforcement. Okay. So, pwedeng ganito yung way. Pwede rin ganito yung way. So, this time, yung itong way na to, okay, they use yung 1,000 millimeter as your total width B. So, they are just considering 1 meter strip. 1 meter strip. Also dito, 1 meter strip. Okay. So, they are just considering yung 1 meter strip. Okay. So, kung kukunin nyo yung spacing nito, kung using itong isang solution, is basically, ang gagawin mo lang ay spacing divided is equals to AB times, hindi siya 1 meter strip. This time, kung considerin mo yung 2,300. Okay. Divided by AS, okay, you get your spacing. Okay, so yan yung ating solution for the for actually loaded footing with axis on the both bending axis. Okay. So, sige, sulat ko na lang din yung to get the spacing using itong isang equation. So, to get the spacing using other equation, that is spacing is equals to AB times ano yung width na ginamit mo. Okay, ano yung total width? Okay, yung total width nyo is 2,300. So, 2,300 divided by the AS. Okay, therefore, your spacing is equals to 3394.8 times 2,300 divided by the, okay, sorry, should be pi over 4. Okay, dapat ito ay pi over 4. Times 20 squared divided by 3394.8. You have your spacing, which is equals to 212.85 millimeter, which is exactly the same 210 millimeters. Okay, so ayan. So ganyan yung pag-solve for this one. Okay, so thank you for listening. Okay, and mabuhay tayong lahat.